is the length? The length is this side, which is 100. The length is 100. And that is how I get my X bar and the volume for the respective parts from the reference point. And where is the reference point? This point of intersection is always the reference point. So we measure all our centroid from the reference point, and every shape has a unique way on how to measure the centroid for X, Y, and Z. But we are still looking at X axis. And all this should be divided by what? The summation of the volume for part 1, for part 2, for part 3. So the sum of volume of part 1 plus the sum of volume for part 2 plus the sum of volume for part 3. And now we would have the volume for part 1, for part 2, for part 3. And so it's very easy to write the sum of the volume. For sum of the volume for part 1, I just have my 550 times 150 times 150 plus for part 2, this is the sum volume for part 2. For part 2, I'm going to have 200 times 200 times 150 times 150. And for part 3, this is the volume, plus half 150 times 150 times 100. And therefore, I have my X bar. If I simplify this expression, my X bar will become what? 120 millimeter. That is actually the distance for that piece for along the X axis. So I'll have along the X axis, which is for this body. So the centroid for this body will lie at a distance of what? The distance of 120. At a distance of 120. Somewhere, the center of gravity for X will lie somewhere around 120 for X axis. So remember that the different shapes has different volume and has different distances, but now we are getting the centroid for the entire body. It's like you are trying to design an aircraft and you have so many different parts for the aircraft, and all those different parts for the aircraft has different center of gravity, and we are trying to get the center of gravity for the entire X, for the entire aircraft on X and on Y and on Z. Even for your car, you have so many parts that are put together for a car to be designed, and all those parts has that different center of gravity for different location. But we may want to get the center of gravity for the entire car, for all the parts, to be able to know the stability of that car. And that's how we get the X centroid for the entire body, for the different parts. And we can equally do that for the Y direction. And so Y become what? Y bar equal to what? Equal to the same formula, but now we are going to change the formula to talk about Y bar volume over the sum of volume. Over the sum of volume. Over the sum of volume. So what is changing here is just that we are using both Y bar only, but the volume will remain the same volume, and the sum of volume will remain the same sum of volume. But then let's see how the Y bar will also change. We start with part 1. So for part 1, remember we are talking about part 1. Let me write the parts again so you don't get confused. And I'm trying to clean this, so I want to clean it so you can clearly see the dimension again so you don't get confused. So we have we have, this is part 1, this is part 2, and this is part 3. So technically, for part 1, we are talking about what? We're talking about the y bar, and this is part 1. This is part 1. We're talking about what? This is the y-axis. We're talking about the y bar. So technically, for y bar, we have 250 millimeter plus 200. We have what? We have 450 plus 100. We have 550. I'm going to have 550 divided by what? 2. It's a rectangle. So the y bar is just the total length divided by 2. And this will give me a value of what? 275. And this is, and I'll have 275 for y bar for part 1. And we've spoken about the volume. It's length times width times height. And that will become what? 150. So the volume is length times width times height. I'll have 150 times 150 times 550. So that is the volume. That's the volume. The volume is equal to length times width times height. That's the volume for that piece. 1. And I move now to what? I move now to part 2. I move now to part 2. And I'll clean this so you can see clearly. So this is part 2. This is part 2. So for part 2, we are still going to use the same concept to be able to get the y bar. And remember, for the y bar, we have a reference distance. But then we are measuring on the y-axis, this direction. So we are measuring on the y-axis. We are measuring on this direction. And therefore, we have 100 plus 250. That gives us 350. That gives us 350. So from the reference point, we have 350. Plus what? Plus I have this distance which I have here, which is actually 200. And I have 200 divided by 2 because the centroid for this piece is actually 200 divided by 2, which is actually 100. So technically, y bar will become what? 350 plus 100. And technically, I'll have y bar as what? 450. And therefore, my y bar now will become what? I'll become 450. And the volume is what? Volume is what? Length times width times height. And therefore, I'm going to have 150 times 150 times 200. Remember, we're talking about the volume for which piece? We're talking about the volume for part 3. We're talking about the volume for part 3. So it is actually 200 times 150 times this thickness, which is 150. And therefore, that's what we have. Plus, we move now to part 3. Let me clean that so you see clearly. That is part 3. We move to part 3. And we are still measuring part 3 on the y-axis. We are measuring on this y-axis direction. And to measure on the y-axis direction for part 3, remember, remember part 3, I have y-axis is equal to what? It's equal to h over 3. It's equal to h over 3. And it's actually, if you want to call it, this side, which I have, I'm moving along this side, so I'm going to have a measurement that is going to be the height for that is still 150. So the height for that piece, is equal to what? The height for that is equal to 150. The height is equal to 150. So, and that 150 is just the height. And if you look at that, if you want to consider that, this is actually the base I'm talking about. This is the base for that. That is the base. So it's 150 divided by 3. I have 150 divided by 3. I have 50. So that is the value for piece 3 for y bar. I have 50. So that value is 50 for y bar for piece 3. And the volume become what? The volume become 1 over 2 length or base times height times length. And what is the base? It's still 150, so the base is 150. It's 50, and the height is 150, and the length is 100. So this is the length 100, this is the base, and this is the height, which is 150. And that is actually for part 3. And what do we have? We have just part 1 and part 2 and part 3 divided by what? The sum of volume. This is the volume for part 1, volume for part 2, volume for part 3. So I have the volume for part 1, I have 150 times 150 times 550 plus the volume for part 2, which is 150 times 150 times 200 plus volume for part 3, which is 1 over 2 times 150 times 150 times 100, and therefore y bar becomes what? Y bar becomes 305 millimeter. So that is the Y bar. So if you look at this piece, the Y bar becomes 350 for the entire body. That is the Y bar for the entire body, for the effective body. And technically, we move now to Z bar. I have the same formula. The sum of Z bar times the volume over the sum of the volume. So it's equal to what? I'm looking at the Z axis. Let me clean this so you can see clearly. I'm looking at the Z axis for part 1, for part 2, and for part 3. So I'm cleaning this so I can be able to write here and you can see clearly. So I have this is the z-axis that you see. So I'm going to look at the x. I'm going to look at part 1, part 2, part 3 centered with respect to the z-axis. So let's start with part 1, which is already what you're already familiar with. So for part 1, I have, this is part 1, and therefore I have along the z-axis I have 150. It therefore means my z bar for part 1 is equal to what? 150 divided by 2, because it's a rectangle, and therefore my z bar is equal to what? 75. Every rectangle, you just divide the length by 2. You're going to get the z bar, the x bar, and the y bar. If you take note, that is what we've been doing for all rectangular shape. It's quite easy to get the x bar for rectangle. So I have 75. And the volume is still length times width times height. The volume is still length times width times height. So the volume is still length times width times height. So 150 is the height, the width is 150, and then I have the length is 200 plus 250 plus 100. I have 550, and therefore I'm going to have 150 times 550 times 550. Sorry about that. Times 550 times 550. That is the volume. And I move to part 2. For part 2, this is my part 2. This is my part 2. This is my part 2. For part 2, what do you have? I have along the z-axis is still 150. It's still 150. So for part 2, along the z-axis is still 150 divided by 2. I still have that 150 divided by 2. So which is still 75. I still have 75. And what is the volume? Volume is still length times width times height times breadth. So I will still have 150. Remember, I'm just talking about the volume of this piece, this piece, this piece, this piece, this piece. So I have 150 times 150 times 200 times 200. So I have 150 times 150, 150 times 150 times 200. And now I move now to part 3. I move now to part 3. For part 3, which is this triangle which I have here, I use the same method. I know for triangle I still have z is equals to what? H over what? 3. And this is the height. And the height is 150. So I have z bar equals to what? 150 divided by 3. Z bar is equals to what? It's equal to 50. So I'm going to have 50, and the volume is still equal to what? 1 over 2 base times height times length. 1 over 2 base times height times length. And what is the base? The base is 150. And what is the height? The height is 150. And what is the length? The length is 100. So this is the length, 100. This is the base, 150. And this is the height, 150. And that is the volume. And that is the volume. So technically you divide by what? Divide by the volume for part 1 plus the volume for part 2 plus the volume for part 3. And technically I'm going to have 150 times 150 times 550 plus 150 times 150 times 200 plus 1/2 times 150 times 150 times 100, and that will give us what? 73.4 millimeters. So technically I have X bar, Y bar and Z bar for the different location is equal to what? Is equal to 120 millimeter, which is X bar, and for Y bar I have 305 Y bar, and for Z bar I have 73.4. So that's how we find the center of gravity for different shapes that forms a unique body. And please, I'm sorry the video is quite long because the problem is always long. So I will do this for you to watch this video before coming to class, so we should be able to have enough time to discuss another problems in class. But always go back to this video if you want to revise your exercise on center of gravity. God bless you and have a wonderful day. Thank you. Bye-bye. Bye-bye.